Welcome to the day in history for June 5th. Today, 1964, is the day that the DSV, or Deep Sea Vehicle, Alvin, is commissioned. Commissioned means put into service. Now, the big idea for today is that technology changes and constantly improves. And we'll see that in these first few slides. So, let's take a look. Okay, here we go. Now, we are located at the NOAA headquarters and the deep sea. I chose the Galapagos Islands because that's a really cool place for this sub to go. But NOAA is the National Oceanic and Atmospheric Agency. They deal with climate and the ocean and a lot of research. And the DSV Alvin has been very important for them. The DSV Alvin, though, is actually owned by the Navy. And the Navy uses it for quite a few things as well. So, let's first talk about the early attempts to go underwater. Because for almost all of human history, we could dive down and hold our breath, but we had to come back up. But as sailing ships got more advanced, and as we were able to create new materials, we wanted to go underwater because there's a lot of cool stuff on water, especially if you accidentally drop it off the side of a ship and you want to get it back. Could you imagine dropping something off the side of the ship and having no possible way to get it? Well, people wanted to solve that problem. And Halley's diving bell from 1691 is that. Now, if you're in the bath and you take a cup, and you take that cup and you put it straight down into the water, have you noticed how you can trap air under there? Yeah, right? You've done that before, and then you tip it and the bubbles come out real quick. But Halley's diving bell is the same idea. If you take a bell and you push it down and you trap the air under there, a person can sit in there for a while until the air runs out. And you can even pump air in there. So they figured out a way to go down and actually breathe underwater. It's pretty crazy. Now, as the 1700s come along, sailors start developing more advanced actual diving suits. And so they would pump air through these flexible tubes, and they would pump air into a helmet. I mean, that's kind of a scary looking helmet, but they would actually pump it down into these suits so that people could walk around and breathe underwater. It's pretty cool. Now, the helmets got more advanced because there were more things they needed to do underwater. So, pretty cool stuff. Now, we talked about this earlier in the year. This is the triste, and you remember that diving bell, or the sphere on the bottom? And we talked about how that sphere is what allowed it to go so deep, and that the ship itself was filled with gasoline because it couldn't be compressed. Now, this was the early version of what we're talking about today, because we realized we needed to improve. This worked really well to go to the bottom and look around, but you couldn't really do much else. And so they developed the Alvin. Now, the Alvin, it looks different, but it has the same idea. It has the same sphere, but it had a lot of improvements to include better viewing ports so you could see better. It had arms that worked like shoulders so that you could reach out and grab stuff. So they made a lot of improvements. And that's why the big idea for today is that we constantly are improving the technology that we use. Now, the design, once you see it like this, you can see that it's very similar to the triste when it comes to where the driver and the scientists sit. It has this giant titanium sphere that I think is it's really thick. But it allowed the Alvin to go very, very, very deep. Now, it had a really cool emergency separation, like an escape pod sort of thing. So if it went down and it got stuck, it could actually eject part of it off and that would go up to the surface. I thought that was a pretty cool addition. Now, when they designed it, they wanted to make that sphere super strong, but add a lot of windows. And you can actually see them putting it together here. I thought that was a really cool picture of them putting that giant sphere in there. Now, the Alvin has been used for a lot of different things. Now, one of the things it's famous for is exploring the ocean floor. Now, the Earth is over 70% water. And when you think about how much humans want to explore, to have that much of our Earth pretty much unexplored, it drove a lot of people, well, kind of made them crazy, and they wanted to explore. Now, there's a lot of other reasons for us to go to the ocean floor, but one of them was to simply see what was there. And scientists used tools like the Alvin to go down and explore, to discover new species. Because a lot of the things that we use today, we got from nature, and there is a lot of nature in the ocean. Now, in 1966, there was a report of a swordfish that got stuck in the Alvin. Took them 2 hours to get it off, but they ended up having it for dinner. Unfortunately, the swordfish didn't survive. Now, the Atlantis is the ship that carries the Alvin around and launches it. And probably one of the most famous things that the Alvin and the the Alvin and the Atlantis discovered was the Titanic. In 1986, it made history, it made huge news when the Alvin discovered the Titanic. And that's a whole other story. We talked a little bit about that with the Titanic Day in history. But now another thing that they're not so famous for, but is pretty important, is in 1966, I think it was over Spain, a B-52 and a refueling plane crashed, and they lost a nuclear bomb in the ocean. And the Alvin spent 3 months looking for this nuclear bomb and eventually actually found it. So that's one of the reasons, other than exploration, that they use these deep sea ships or deep sea submarines. Now, what I find absolutely fascinating, though, is their research on deep sea hydrothermal vents. And there's a couple reasons. Because the life that we find that deep in the ocean looks totally different than a lot of the stuff we see on land. And the research into these hydrothermal vents is pretty interesting. Now, a hydrothermal vent is it's like a hot spring on the ocean floor. So if you've been to Yellowstone, or if you've seen those like bubbling, super hot pools of water, it's the same thing, but happening on the ocean floor. So what happens is there's hot like magma under the crust of the ocean, and it kind of the heat starts to come up. It mixes with some seawater, and it creates like a constantly shooting volcano of hot water out of the ocean floor, and it's spewing minerals and metals and all kinds of nutrients into the ocean that settle down and create an entire ecosystem that doesn't have anything to do with sunlight or the things that we normally think about for life. It's a whole different environment, because once you get farther away from these hydrothermal vents, it's crazy cold and there's like hardly anything there. But around these hydrothermal vents is all kinds of really interesting life. Now, Europa is a moon of Jupiter, and many scientists believe that there's a liquid ocean on Europa, and scientists have seen volcanic explosions coming off Europa, saying that there's volcanic activity. So, if you take the fact that there's an ocean probably on Europa and volcanoes, you might surmise that there are hydrothermal vents on Europa, which means there could possibly be life on Europa. And in the late 2020s, NASA is working on sending a probe to Europa to try and test out this theory. Wouldn't that be absolutely amazing to find life on a hydrothermal vent orbiting Jupiter? That would be really cool. Today's Day in History, I hope you liked it. I'll see you guys on Monday.